This is the GFG POTD question, minimum element in binary search tree. So the problem states that given the root of a binary search tree, our task is to find the minimum valued element in the BST. So let's solve this. So I've taken these two examples that were given in the question itself. So let's solve. As we know that BST states that the left subtree is always lesser than the root and the right subtree is always greater than the root. It's correct here also. So since we have been asked to find the minimum element, so it's obvious that we will find the minimum element here only. We will find the minimum element in the left subtree only, as you can see here. So what approach we can move forward with is we can move forward with this approach is we will first traverse the left subtree, and until and unless uh, we reach a null value, we won't stop, because if we reach the null value, then that means this element is the minimum value. This element is the minimum value. So until and unless null value is reached, we will traverse. Okay, so let's try run it. We will also check for the edge cases if the tree is empty or not. Uh, so is so there is a root we can see. So do we have any left node? Yes, we have. So null value is not reached. Do we have any left node of 4? Do we have? Yes, we have. That is 3. Do we have any left node here? Yes, we have. That is 1. But we won't stop here because we haven't reached the null value. So we will look for the left node. Finally we will reach the null value. So here we will stop and we will return this as the minimum value. Similarly, we can see that we don't have any left subtree here, and the right subtree is greater than the root. So let's repeat the same process here also, repeat the same steps here also. So we can see that we just have a single root. We don't have any root in the left side, any node in the left side of this root. So we will return this node only because this one is the minimum. Now let's implement the coding part. If root equals to null, then return -1. Now we will start traversing. If the tree is empty, if we don't have any root or the tree is empty. Similarly, while root left not equals to null, root equals to root left, and after reaching the last node, we will return the data. So again, let's try run this code. Is the root null? No. So we will move to this part. While root left not equals to null, root left not equals to null. No, we don't have any null value, so root equals to root left. So now it will be pointing to 4. So do we have any root node here, left node here? While root left not equals to null, yes, it is not equals to null. So now it will be pointing to 3. So again, while root left not equals to null, yes, it is not equals to null. So root equals to root left, again it will be pointing to 1. Now, while root left not equals to null, no, it is equals to null. We don't have any value left further to traverse. So we will return here this root value. Let's run this code. Okay, here I'm getting some errors. Redefinition. Yeah, so here you can see this thing has been redeclared. So I think this will solve the problem. Compile and run. Yeah, it's giving us the correct output. Let's submit. So yes, it's successfully solved. Thanks for watching.